The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Welcome to our webinar, EquatIO, More Ways and Places to Make Math Digital. Thank you all for joining us either this evening or afternoon or morning, depending on where in the world you are, but we appreciate you being here. My name is Dina Kimmel. I'm part of the marketing team at TextHelp, and I'll be helping to moderate the webinar today. I also have Kathleen with me, and she'll be helping answer questions as we go along. You'll see that there's a little question chat box in your GoToWebinar panel. So throughout the webinar, if you have any questions, please put them there, and we will either answer them via text, or then we'll save them for the end when we have kind of a Q&A for John. Before I send it over to John, I just wanted to remind you of the Twitter contest that we're having. We have a hashtag #MakeMathTogether, which you'll see at the bottom of the slide. Throughout the webinar, if you see anything that you're excited about or find interesting, or a quote that John says that you like, feel free to share it on Twitter with the hashtag, and one post will win, and that author will win a free year's subscription of EquatIO. So get your Twitter fingers ready, and we will announce the winner probably early next week. This webinar is also being recorded, so we'll be sending out the recording early next week as well. So without further ado, let me introduce John McGowan. Some of you may already know him, but if you don't, he is the product manager and visionary behind EquatIO, which is our STEM solution. Prior to joining TextHelp, John taught secondary math for over 15 years and loved to adapt the fail-forward mentality and push the bounds of technology integration in the math classroom. This led to the development of GMath, which some of you have probably used, which was a Google add-on for docs, sheets, and forms, which was the first iteration of what is now EquatIO. So without further ado, I will hand it over to John. Let me just make you the presenter. All right.
All right. I think, are you guys seeing my screen? Are you all seeing my screen?
Yep. Looks good.
Perfect. Thank you so much, Dina. I really appreciate it. And Kathleen, thanks again. And to all of the people out there on the webinar, I really appreciate you taking out of your valuable time to come listen to us talk about EquatIO and how we're going to make math digital, make it easy and accessible. So I'm really excited to talk about it and to share with you. So a little bit of a refresher about EquatIO. So EquatIO is essentially a nice way to easily create digital math. So, and also we are going into the STEM field. So as Dina referenced, I made GMath, and that brought me to TextHelp, and it's been so amazing. I love working with the team here, and we are moving beyond just math and going into the whole STEM field. So the basic point is it's an accessibility problem to go from pen and paper to the computers. We want to utilize technology, and it's an accessibility problem to do that, and TextHelp's awesome with accessibility. And so if it's a notational component, we want to make it easy to make, whether it has science notation, math notation, all of that involved. We want to try to conquer that and make it really easy, intuitive, fun, and delightful to make, and to really empower students to communicate their thought process. That's the guiding mission that I feel like I have as I help guide the EquatIO product, is really just to allow students to empower them to communicate how they feel, what they think about, and that's the whole goal there. And so we built it on a universal design for learning platform, and I think about it as just choice. Like, we want to allow students to respond in the method that they prefer, whether it's verbally, using handwriting. I love the prediction method, and I'll talk a little bit about why I think that's awesome from a pedagogical standpoint in a minute. And also, if they know LaTeX, that's awesome. Like, I don't want anyone to ever have to learn LaTeX, but LaTeX is, if they do know how to use it, great. We enable them to use that as well. And then it also integrates seamlessly with Read and Write, which delivers math-to-speech capabilities, which, again, I love that from a variety of standpoints. So one, it's accessible technology. It's required for some, but awesome for all. There's some of those kids who just need that to enable them and empower them for success. And we can now read aloud all of this math or science notation as it should be read out from the teacher standpoint. And so that's really in a nutshell what it is. We want to make it easy to make their thought process digital in a variety of manners, and then it can be read back aloud, and it's also accessible. So I'm excited to be able to bring that to everybody, and we're always constantly iterating on that and adding new features. So we have a huge roadmap of all these improvements and features that we're going to be bringing in the next year to 2 years. So I'm really excited. And so I referenced it from a pedagogical standpoint. So I think from a notational component in math and science, and these all say math, but I also feel like the science is the same exact problem, is that it's a pain point. There's math notation and math terminology, and those are two things that are new as we're trying to teach an underlying concept. And the digital component, like, it's difficult for students to create the notation if they don't know the terminology yet, and there's no button on the keyboard for that. So that's a big problem. So we want to try to break those two barriers down. These are barriers to learning, I feel like, the notational component and the new terminology. And so if we can bring those two barriers, then we can allow the students to attack displaying their understanding of the underlying math or science concept. And so that's really what EquatIO is geared towards, is to bring down those notation and terminology barriers and really get to the heart of the student's understanding and communicate that thought process. And from the teacher standpoint too. And I'll talk about that in a little bit as well, how I think the teacher standpoint comes into it. So let's think back about, just to go back, what did EquatIO look like in its iterations? The first iteration we launched was the EquatIO for Google. So that's our Chrome extension, and it's been out since April, and now it works in the full G Suite in docs, forms, slides, sheets, drawings, even form responses, which is a great way to do formative assessments. I love to give 3 quick questions for a warm-up and then allow my students to respond with EquatIO to, then I can instantly see as the answers come in, do they know it, do they not? That can inform my instruction for the day. So that's really a great point. And the different ways of input in there are, we have the speech input, the handwriting recognition, math writing shortcuts, LaTeX, and math, chemistry, and formula prediction. And all of those features are in the next product that I'm going to talk about, which is we've now moved on into EquatIO for Microsoft Word. So we have EquatIO for Windows and EquatIO for Mac. Both of those now EquatIO is an installable app. So you can go to our website, and then you can click on whatever device you want to use, your Windows or your Mac. You download that, install it directly on your computer, and now you can open up those Microsoft Word documents and have that same ease of integration into Microsoft Word. So just like we insert into Google Docs, we now insert into Microsoft Word. And so I'm really excited by that, because for me as a teacher, I have so many resources that I've used with Microsoft Word, and then now I can reuse them. It gives them a new life where I can actually edit them. I can send them to students and allow them to respond in those documents with EquatIO as well. So it's really adding a lot of features to resources that I have already created, and especially other teachers. And I think that for me is also in the forefront of my mind, is teacher time is the most valuable thing they have, and I don't want you to waste it. So if you've spent tons of time, like I have, creating resources and you want to use them again, we want to enable you and empower you to do that. So let's just go to a quick demo. So I am using a Windows machine, and I have my Microsoft Word document up, and so I might have, I had that in there from before. So the best part about EquatIO, all I have to do is I have my normal Word doc up, and EquatIO, I pop it open, and it's going to install and put a little toolbar on the bottom of my screen, and those are going to show me my input methods. And so I have the equation editor, I have a LaTeX editor, handwriting recognition, and speech input. And so I can enter in any of those 4 ways and then interact with any of the others in the same vein. So I can do a multimodal response. So for instance, if I wanted to talk about square root, it's really difficult for students to create that learning and the thought process digital because the lack of keyboard keys for math notation, and we're also working within the constraints of a document that's pretty much geared for pros, so not for math and science notation. So there's some typesetting issues that we want to address. So for instance, with our prediction, if I wanted to make a square root, I can just start typing the phrase square root. I type SQ, and then we will populate with all of the math terminology and the notation associated with it that we think it's in there. So I can be meaning squared or square root. So that, for me, from a pedagogical standpoint, is awesome. It's great for students who are just learning the topic. They don't need to automatically know what the symbol is, which is what every other equation editor does. They make you find the picture of the symbol, and then you press that to be able to insert it. So by putting the phrase, if I'm a student in a classroom, my teacher starts writing about square root, then I can just write the words that they have, or start typing those letters, and it'll populate up. And then enter, I hit enter, and then it makes the square root for me. That's also great for English language learners who might know what the concept is, but can't relate the word or the terminology to the notation. So that's a really great example. Then I also, wherever my cursor is in the document, I come back over here, I click Insert Math, and then it automatically inserts that into my Microsoft Word document wherever my cursor lies. And then the best part about that, again, from a pedagogical standpoint, Read and Write will come by and read that out aloud. So now it's automatically accessible. So not only is it easier to use, I believe, it's also going to be really great from an accessibility standpoint. So I'm going to pull my headphones out, play it with Read and Write, and hopefully you'll hear it.
Example, square root of 4. Solve the following equation for x, 3x squared.
So that's the great part about that. It reads it out directly as me as a math teacher would want it to be read. So it reads it as square root of 4 and not with the complicated LaTeX or typesetting notation that's required to build it, like most accessibility components. So that's really awesome, especially for, again, students who are struggling, students who are learning, English language learners, to understand when that is read aloud, they can help cement what is that understanding between the notation and the symbol in there, and the notation and the terminology. So that's a great way. The prediction method is a great way to have students enter it in there. And for me, honestly, when I type a lot, like if I want to do like 3x squared plus 15, I now will just type it faster with that prediction because it's as my brain is thinking about it. So I hit PL enter instead of stretching for the plus key. And so those are just great ways for me to just express my thoughts more quickly, and so that I could be more fluid and then feel like I'm in that flow of communicating and not have to think about, okay, where's that button I need to find, which is not me communicating, it's more the process of me trying to make my math digital, which, to be honest, is what I found was the frustration of students. Like, I love math, I want to communicate it, and my students weren't really willing, or really they shouldn't have to put up with the time necessary to make their math digital. So this is why I think EquatIO makes it a lot better. I'm going to skip over to LaTeX for now, but I'm going to go to handwriting recognition. Again, like, I want students to work in the method that they prefer best. If they just want to do some handwriting, I have a touch screen here. It's the Acer Spin 11, I think, or Spin 5. But I can just start writing on my touch screen, and we will render what we think it says, and it just updates that in real time. And then if I insert that math, it's going to be automatically accessible, which to me just blows my mind. It's something I'm handwriting, so it's like some physical component that directly gets inserted, and then now it can be read aloud. So it's just a great way for us to go from something real world to something digital, and then also accessible automatically. I had a college professor who said that they loved it because they were able to make their document accessible easily. They just gave the printout of the document, and somebody in the accessibility office was able to make the math and make it accessible without having to fully understand all of the math within there to make it. So it saved them a lot of time. So I love hearing stories like that where it just saves teachers time, and it's just a win-win-win for everybody involved, from the teacher, the student gets to feel empowered, and everybody around feels like it's a good situation. So that's our handwriting recognition piece. We can do handwriting, and then also we can combine that. So if I wanted to do 3x cubed and it didn't like that 3 over there because my handwriting's not so great, I can come over here and I can click on that to then start editing if I want to with prediction. So I can come over here and say, oh, I want to do 3x cubed. And then maybe if I want, I can continue going, like if I want y times the square root of 4 squared. And so I can just start typing on those. And I might even say I want that all over 4. And maybe I want all of that over 2a. And so I can just start doing whatever I want to type. And then I want 2 to the power of n. And so I think that's the thing that I think about, is it really gets from this flow of consciousness of when I want to put my math in, and just really make it easy to make those structures in there. And then finally, we have the input method of speech input. I'll actually, not finally, I'll go back to LaTeX, where I can just record whatever I want. And we've really improved the speech input where it filters out non-math terms, but then also tells us what we think you're saying, so then you can correct it and help render that math, because my workflow to make emails all the time is talk to my phone, and it doesn't get it right all the time, so I have to go back through and then edit it with prediction, and then I might go in and type it again. So I tried to mimic that workflow. X squared plus 4x plus 4 equals 10. And so you might notice it got pretty close. I wanted x squared instead of a squared, so I can just say I wanted x squared, and it'll put it in there. And I can also come over here and start using the prediction here. So I could say I wanted x squared as well. So that's one way that I could start with speech and then go fix it with something else. I can even say, I can then add over here, if I want to go from handwriting, maybe I wanted 4 times the square root of y, and it could then edit that. So I can then edit with some insert handwriting recognition within that document. So that's really exciting to be able to use that multimodal input and then be able to insert that directly into my Microsoft Word document, and really empower students to use the documents that their teachers already have created, and then be able to then use the method they prefer to talk or handwrite or use prediction, and inject that into the Word document, and then turn it back into the teacher to allow the teacher to accept it in the method that they prefer, which might be digital. So I love EquatIO as that bridge. It's like I think about it as like a UDL bridge. So the student can respond however they want and interact with the math and science however they want to, but then it's digital, so they can give it back to the teacher, and the teacher can then consume it in the manner that they prefer as well. So I think that is a great bridge to just really enable everybody to be working in the methods that they prefer. And I love it from shifting for students who, I believe that most students who struggle in math or science, it's because I feel like as math teachers are so rigid in what we deem as the way that students need to respond, and that's based a lot on the learning style, which becomes of a teacher, and becomes the teaching style, their default teaching style. And so it enables students to learn in other ways and communicate in other ways than is their teacher's preferred method. And then the teacher can still be happy and accept it. So I love that component. Just make everybody happy. So that's how we work in Microsoft Word. I'm really excited by that component, and now we can just really make it fun, intuitive, and delightful to make math in Word. And I'm so excited to fire up some of my old Word documents that I spent so long creating and formatting, and just making them to be accessible and digitized. It's great. So let's go back. That was our demo there, and I want to talk about another feature of EquatIO. And actually, I continually forget to talk a little bit more about our prediction. We have a few other prediction items in there. We have the math, but we also have chemistry and formulas. And by default, when you install, we toggle these off. You just have to go to options, turn them on, and now we have some other prediction options. So if I start typing QU, it'll give me the quadratic formula or some other formulas that I have. And those are notationally really difficult or cumbersome. For instance, if I want to look at the LaTeX of that, this is the LaTeX typesetting, which is, I don't want any student to ever have to learn that to be able to represent their thoughts. If they do want to learn it, it's a great method to use our prediction, because I could do like 3/4, and they can find out that I do /frac, braces 3, braces 4, and that's how I can create the LaTeX there. So if you really want to use LaTeX, you can. We also have some pre-populated buttons that I hid down here, because math teachers are trained to look for the buttons to click, and I don't want them to click on buttons. But UDL says, hey, if that's your preference, go for it. You can find some of these and then put them in, and we can do that. And then we also have chemical notation. So like maybe I want to do sodium aluminate. So I can just start typing SO, and then it'll give the notational component for that with the subscripts. And we have over 1,000 chemical compounds. I'm really excited by just the way that we can create some of those. Shout out to my friend Efren Rodriguez, who is really my chemistry consultant, and he'll tell me what we need to put in there. Like he'll be doing a unit on the ideal gas law, so we can put that in there. So I'm really excited by those, to be able to take whatever that grassroots effort from teachers. I honestly feel like GMath was so successful because teachers helped me make it better and helped give feedback as to what they want to do to make it useful. So keep telling us what things are need to be in there. Like nuclear notation we have in there, and a teacher, I asked, what do you have an element that you want to use as the base? And she was like, yes, Tennessee, I'm from Tennessee. I think her name was Deanna, and she's from Tennessee. So we love that input. And even like scientific notation, I can do like 4 and then PO for 0.6. And if I want, just do TI for times and then 10 to the power of 4. So that's an easy way, I think, for the way that I say scientific notation to flow for a student thought. But even since it's always like times 10 to something, they can just do SC for scientific notation, and we populate that times 10. So again, if it's a notational component you want us to be able to do, then we can bring them in there and make it easier to make digital as well. So I love that component. One of my favorite things, I taught AP Stats for a long time, and if I want my students to do the correlational coefficient, they are never going to type this formula up, but they'll easily be able to insert it with prediction, and then they'll copy and paste, so I'll get to see more of their thought process as well. So that's an added benefit. Since it is easier, they can use technology like copy and paste to continue to write from one step to the next. And honestly, many of my students make errors. They're transcription errors, moving from one line down to the next. They miscopy what their previous work was. So copy and pasting will help eliminate some of those, I call them silly transcriptional errors. So that's how we can work in broadening out. We have a lot of physics formulas that are coming in. I'd like to see more as well. So please let us know if there's things that are missing in our prediction method and also in our speech input. We're constantly adding more and more in there. From there, I want to talk about making math together. So that's really the end goal as well, is to be able to communicate in a flowing conversation and more than just inserting math into a document, which is awesome. It's great. It's a great step, but it's really not fully what I need to do or want to do. So today we're also going to talk about EquatIO Math Space, which currently it is just a web app. It's based in Google Chrome currently for now, but it allows you to just use a web-based system to be able to create more than just one thought. So currently EquatIO for Google, or EquatIO for Windows, or EquatIO for Mac lets you put one equation or one expression, or you can do some multi-line work if you're using LaTeX or handwriting recognition or speech input. But it's really like one thing. And so this our EquatIO Math Space is going to allow you to do multiple things, put multiple equations, multiple representations of things. We're going to have some sketches, some diagrams. We have a larger workspace. And we also are really, I think about it as like a digital lab notebook in the science field. You could sketch out any sketches that you might need to do, but also for elementary students, like we really are, I want a third grader to be able to easily communicate their thought process. And I don't want them to have to think about typing, or maybe they're learning notation. I want it just to be seamless and simple. So that's the other component that we're bringing in, is new methods to make their math digital. And then finally, the sharing component. So we introduced a sharing component here, so you can share outside of the G Suite or outside of a document-based system, where it'll just share directly to each other. So I can get that back from my student and give feedback quicker. Because to quote my friend Alice Keeler, we really want to shrink that feedback time. Like literally, there's I think in inverse proportion, the time that it takes me to respond to my students and how much they actually care. So it's a really great way to be able to just respond and give feedback quicker. So let's go ahead and jump into that demo. So how do we do that? Well, first you just go to equatio.texthelp.com and we'll automatically load it up. The first time you will have to log in, because you'll see my little picture up there. It knows who I am as I logged in. I just logged in with my Google. We have 5 different ways you can log in. You can log in with Twitter, your Microsoft, LinkedIn, and maybe Facebook. I'm not really quite sure about that last one. I always use the Google one, but if you have a Microsoft email, you can log in with that. And so now I have the same tools, but I also have some more. So I can put in my normal things that I want, but I can also have this text mode area. So text mode is a new way that I can input, and I can do text. So I might say something like show or find the divisors of 12. And I can insert that, and so it gives me a text area that I can move around, and I can drag, and I can hit return, and I can do some things that I want in there. And so that's a great way that I can put that in there. But now I also might want to have students be able to use some manipulatives. So I can come over here to these shapes, and I can just drop a circle out here, and I can click on that if I want. And I'm going to make it a little smaller, and I want to change the color. And there we go, make it EquatIO blue. And so that's a nice way where I can create something and say, well, I want 12 of them. So I literally just copy and paste them out. That's 5, 6, 7, 8, 9, 10, 11, 12. So now I have 12 little discs that I can share with my students and they can work with. So I can prompt them. I love the fact, too, that I can also scaffold this. I can use them without the counting discs. and I can also scaffold it up to give different levels of that. So I can cut these off. So let's say if I copy those and then cut them out, I can share this out to my students, and they can respond. So I might have 3 different groups of learners in my Google Classroom group, and I have students who don't need any scaffolding or don't need any prompts, and maybe students who are at different levels and they need at different stages of their understanding, they need different instructions. So the sharing part is all I have to do is if I have one of these math spaces, the EquatIO math space, I just click on share, and then I have 2 types. I can make a copy for each person, which just literally gives them a copy of it, and then they can work from there. Or I can make a copy from each person and expect a response. So I'm going to toggle, this also is toggled on. So why is that? What's going to happen is when my student finishes, they're going to return it, and then it's going to send me an email. So I have to say, I'm okay getting an email back. If you don't want to, we won't know that your student returned it. So we're working on some of that stuff. But literally it's just, it creates a short URL. I can copy that and then share that. I can project it. I can share it via Classroom, Google+, Facebook, Twitter, and then I can just post that. So if a student goes in the URL and puts that in the URL bar in Google Chrome, it's going to open up now, and it's going to be a little bit changed. And so this now is to submit. So if I'm a student, I can do a variety of ways. I also have a handwriting thing, so I might just start writing 1, 12, 2, 6, and then 3 and 4. So I might say that that's what I want to submit back to my teacher. And so if I click on submit, what it's going to do is it's going to then go and then send an email to my teacher saying, I'm done with this assignment. And so when I click OK, now that was me as a student. As I go back, and notice if I go back to the template, it hasn't changed because the student literally got their own copy. So if I go into my email, I can see that I have an email from there, and it'll say, where's the most recent one? It'll say that my student has submitted a response, and I can click on here and view that response. So now it'll automatically prompt that open. This is the student's response, and I can leave feedback. So I can do in text mode and say like, great job. Or I might say, can you provide visual evidence? And then I can insert that in there. And then one of the other parts that I can do is I can put this wherever I want, and I can change the font color, and they can understand that that's my feedback there. So then I can then create that whole, share that back. I can share it to them in whatever method that I want to. We also have a great workflow coming where that'll be a seamless thing where I won't have to share it again. But just think how quickly that feedback that student's going to get back is within minutes. They're going to be more willing to go back in there and add some thought process. I also love it from the standpoint of, like I was saying, for the couple different levels, that was one student who didn't need any scaffolding, but if I just paste those 12 back in there, I can say now to the student, I might change the instructions up and say, you can extract something that's already written. I might say, using the counting discs, show that 3 divides 12. And so now I can prompt my student with a little bit more focused instructions and then give them some manipulatives to work with. And then I can share that process out again. And I have a separate URL that's always going to do that. So that's like the same thing if I go to my Google Classroom and share different document with different groups of students. It's differentiated work. And I can really have a lot of different leveled tasks that hit upon the same thing. And then my student can just go and just drag those out and put them into groups of 3, and that way they can show that. So I can then say, okay, I have 4 groups of 3, and that would tell me then 1, 2, 3, 4, and then the student can then come over here if they want to speech input and say 3 times 4 equals 12. And so that, I think, an elementary learner can easily manipulate and communicate their thought process and give some great understanding without having to know any notation. They get the time symbol that they want, and then they can share this back to the teacher. In that same method, all they have to do is click send, and then for me as the teacher, it'll come back and I'll be able to see that that student has finished up, and I can continue to engage in them with that work. So I'm really excited by the ability to utilize manipulatives and visual instructions. We have a long list of shapes and manipulatives in here that students can use, and we also, if you feel like we need more, then we can bring them out. So I'm excited to add those in there. I also want to highlight a few other things in here that I think that they could be really useful, and also feedback that we've gotten from EquatIO and Chrome that we really want to do. So one of the things about the text mode is I can add some other higher questions and get more multiple lines of work. So I might have something here in this text mode, I can say solve, and then if I just click on this button over here or hit the $ as a keyboard toggle, it goes back to my math. So this little blue box is a math input area with my prediction. So I can utilize this equation to say, if I want to say solve this equation. And now if I insert that, the beautiful part is it's a crisp image. If I want to make it, I can hold shift and drag down and just really make it huge. It won't be pixelated. That's great for a projector. And then it's also just great for me to just share that out. So now I might have a prompt that I want students to work with, and I can get my image size to be very similar. So then a student can then respond and say, okay, well, I'm going to solve this. I can start off with the problem that they had, and then I can just hit return, and then now I have a new line where I can just do a new line of there, and I can say parentheses of x plus 2, and then I'll say squared equals 0, and I can even then type, I can hit tab or the right arrow to move out of there, and I can say, I can tell what I'm doing, I'm factoring, and then hit new line, or enter, and then go down to the new line, and then I can just say x plus 2 equals 0, and then I can finish it up saying x equals -2. So now as a student I can show my work using multiple lines with prediction, and it's going to be super nice. The text is in line, it doesn't float up any higher, so it's a really tight formatting. It looks professional, it looks like it's come out of a textbook. So I'm really excited to be able to do that. And they might also show, I can drop in a Cartesian coordinate plane, where if I want to sketch a plot of what is that going to look like, and I could then just take my freehand drawing and sketch what I think that looks like. So I'll say x squared plus 4x plus 4. And so I could get a sketch in there and then just really communicate fully what my thought process is. So I'm excited to be able to do that and allow a bigger space for students to be able to communicate from. And there's tons and tons of shapes in here that I'm really happy that we can use. One of my favorite ones I like to highlight is we have a bunch of fraction bars, but I have a parallel lines with the transversal. When I was teaching geometry, I always was making these, so it's really easy to drop that down and then talk about angles. So all those structures that take time to do, we want to make them easy to construct. I also love the idea of just plotting points or practicing labeling. We have blank coordinate planes. It'll just be a great way to have students communicate more than just one of their one line of thoughts. So that's what I'm really excited by with EquatIO MathSpace. And then finally, from there, one of the things you might have noticed is I was thinking, oh, I'd love to have a really awesome graph that comes out of there as well. And so I'm super excited to talk about our partnership with Desmos. So now, if we wanted to throw an awesome graph in there, we have to use the experts. I'm really happy that we're going to be able to partner with them. Desmos is the best in graphing, and so now Desmos and EquatIO is just going to lead us to exponential opportunities. So currently in MathSpace, we have the graphs, the blank coordinates planes that you can pull out and sketch on. Next, in the middle of October, we're going to release Desmos integration, and so there'll be a button on there that you'll be able to build a graph, and you'll be able to drop it into that space and just really add that extra feature and extra component. And I know a lot of our EquatIO Chrome extension users have been asking for a graphing component because there was a free graphing component in GMath, and so we've really been waiting to bring a much better exposure and experience for graphing into EquatIO. So once we get into EquatIO MathSpace in the middle of October, it's going to soon follow into EquatIO for Google and Windows and Mac. So we're going to be able to put Desmos graphs into Microsoft Word or drop a Desmos graph into your Google Doc, or just really to be able to communicate that thought process is super awesome for me. And we'll have a free component in there as well. I do want to quickly highlight one thing that I can do is I can download this as a PNG, so that whole map space, and I can go to a Google Doc, and now I can just show this in my folder since I'm on Windows, and I can literally just drag and drop that into my Word document. And so it literally just worked when I tested it out before time. It must not have popped in there. I can also use the insert, my insert images if I want to drop that in. There we go. It'll put that directly into a Google Doc or anywhere I can do an insert image in my G Suite, and it'll work into Microsoft as well. So really we can have that communication and thought process be super rich and have that inline as well. So what is that going to look like? Well, I have to be on my VPN here, so we just did a quick demo video that you can see that third button, the graph editor, a full Desmos jumps up in there, and then I can use prediction to type in that. Really, it's an awesome way to use all of our UDL insert approaches and make that digital graph from Desmos. So it's another way to input into Desmos and just really enhance all those Desmos awesomeness. If you have a great Desmos graph you want to use as well, we can easily insert that by putting it in. So I'm super excited to make that happen and to integrate with the best graph editor out there. So EquatIO is getting exponentially better. You can ask my students. I can continue to talk forever. I would love to answer questions that might have come up. So hopefully, Dina or Kathleen, you can we have some questions that might have come up or something to highlight that I might have missed.
Yes, we have gotten a few questions. So let's kick things off with one that everybody is dying to know about. It's the pricing and kind of how it combines with the current product, EquatIO, for Google, and kind of what you get with premium versus freemium and all of that fun stuff.
Awesome. Yeah, so the pricing is, it starts off as low as $1 if you go domain wide, and the free part is the tools. It mirrors what we have that is free in Google Docs. So all of this that you see will be included in EquatIO MathSpace. The premium components are these shapes that you want to do, and then you only have 2 handwriting inserts per day, and then the prediction component is premium. So if I want to do x squared, the squared prediction part is the premium. And then the text mode is free, but if I put math, so I can make normal math, but if I want to do prediction part in that math, the prediction within there is also a premium component. So if you're just using the free part, you can still make your math. You just have to know the keyboard math writing tips that we have, like use caret to do the squared part. So that's the breakdown there. And then if you already are, and so the same thing follows in Microsoft Word. The prediction is something that's premium. The other premium is unlimited handwriting recognition. The free part only gets 2. And so that's the premium parts of Microsoft Word integration is prediction and unlimited handwriting. So if you already have premium EquatIO, all you have to do is log in with the provider that has the free thing. So if you have a free Chrome extension, then if you have the premium Chrome extension, then you can be premium once you log in with that same Gmail in EquatIO MathSpace or within the EquatIO or Microsoft Word. So it's the same premium across all things. And also you can now also install the Microsoft Word version. So if you've been using the Chrome extension in premium, your domain has bought it, install the Microsoft Word part, and you can utilize it there on your Mac or your PC, and you'll have all those premium features already with you.
Awesome, thank you. Yeah, so just to reiterate, it's essentially a family plan. So if you purchase any of the platforms, you get all of the platforms for that one cost. And we should note that if you are using a free version, you're going to get all of the premium features across MathSpace and the EquatIO for Windows and EquatIO for Mac for free until November 6th, so that you can try all of those features. Okay, we got one question. Will there be an exam mode, which many education systems around the world require?
So we're working on doing that. We do have ways that we can change what we can do from a standpoint. So that is something that we're working on. If you have some specific information, you can email us. But something that was definitely on our mind is how to be able to use it for assessments as well. So it's definitely on our roadmap and something that would be possible to do.
Great.
In the future, not today. Like if you want to use it for your test today, we can't lock those down quite yet. We still have a couple other features that we're going to build in, like the Desmos integration, and then we can start working on some of those other things.
Does it have the capability for geometric notation?
Yes, so in the prediction part, we have a ton of geometry things in here. So if I wanted to do like, I could do like angle ABC is congruent to angle DEF. So I can do something like that really easily. We predict almost a lot of different things. I have triangles and squares. So we can predict a lot of those. And if you can't predict it, we can draw them with the shapes. So you can drop it in a shape and then be able to use the text to be able to create the notation around the components as well, or handwrite. So we have a lot of things in there. We even have like rays and line segments. So you can make ray AB if I want. And then we even have line segment L if I want. So we have a lot of those geometric notations, yes. We're still working on the one that I still am trying to get is arc. We also have a lot of arrows that I don't know what they need to do for chemistry. But like if I want to do an arc that doesn't work yet, we have to use just LaTeX, and it's still not great. That's the one last thing, that and a full line we don't do yet. You can do it with LaTeX, but not in our prediction.
Thank you. Let's see, we've got one question about where EquatIO Math Space will be available. If you'll be able to eventually use some of those resources in Word as well, or if it's just going to be a web app, and if so, which browsers will it be on?
Yeah, so we're going to bring it to other browsers and then also incorporate some of the features into EquatIO for Windows and Mac. So for instance, the Desmos part, we're going to be bringing Desmos into there once it comes into here. And then some of the other things is this text mode we're looking to bring in there as well. So we're going to try to get into other browsers first to make it compatible with the other browsers out there. And then by doing that, it should open up some stuff, and then we can put some of the other features in. It's just a matter of prioritizing what we can do. We have, only limited resources of personnel that we can put in there. So we have so many things we want to do. Because I know, for instance, like an iPad integration would be great. The Chrome on an iPad in iOS is different. So we're looking at how we can solve that problem as well. So that's definitely in our short-term future to have like an iOS app that enables us to utilize those capabilities.
Great, thank you.
Yeah.
There were some questions about what currently works with read and write, and kind of what it can read and what it will eventually be able to read aloud.
Sure. So read and write can read aloud in Microsoft Word. It'll read the math in there, whether you're on Windows or in Mac. And then we got a question earlier today, which ones? I'm pretty sure we're going to release in High Sierra as well soon. So we should work in the latest versions now. And in the EquatIO Math Space, we don't have any accessibility built in currently. So we have that planned for, because we've just launched it out, so read and write has to, we can make the math, and then read and write has to play well with it since we don't have any alt text on there, but that is definitely in our short-term roadmap as well, to be able to make this accessible in the math space.
Awesome. Sorry, one second. What about writing values next to a geometric figure?
Sure. So I could do a variety of things. Let's assume that just this square, if I wanted to, I can just come in here to this text area if I want, and I can, or I can do, so if I want, I can say 6 and then like centimeters squared, and I can insert that in there, and then just drag it down to wherever I want, and then I can utilize arrows or a variety of other ways to do that. So that's one way I could label those. I can also just straight handwrite them using the freehand drawing. I can say something like that's 4, or something along those lines. We also are working on some measurement tools so that you can drop them out on top of there like a ruler or a protractor, and they'll be fixed to length so you can utilize those. So that's how I would envision labeling them. I can even just start typing in here as well. If I didn't want to use math, I could just start, I could type like CM and label it on there to drop out to bridge next to my shape that I have. So that's kind of the way that I envision it can do. And then we do have, in the longer run, some of these shapes we can figure out what those angles are and be able to toggle those on and off. So that's something that we're doing in the future for in the longer run. But we just want to make sure it works really well. So yeah.
And now, can the student search the shapes by audio input at the moment?
Not at the moment. Currently, they can just type in there. So we're working. That's a great. We could probably just put in that speech. We didn't think about searching by audio. That's a great feedback. So currently, no. But we'd like. We should put that in there.
And we did have a question. Since we do have a little bit of time, somebody asked if we could do a quick demo of how to use EquatIO in forms. So
sure, we could do that.
Early.
Yeah, let's go with that. I also wanted to give a shout out to Fawn Wen's visual patterns are awesome. So I think like this is great for students. I love it if I'm creating it, like to connect up to make spaces. So I can see, I can literally copy and say like, if I want to make the next one, what do I do? And I can pick out some things on there and just copy and paste and drag them out and see how am I going to build that next one. So I'm really excited by that ability to use open middle, which I can do with a lot of squares. If I type my predicting with squares, it makes it easy to create open middle problems and then also visual pattern problems. Yeah, so let's do an example with forms. So I can just go to forms.google.com/create, and that'll allow me to go to the Google Forms. And if I have EquatIO installed, when I want to make up my question, I have this extra little blue box here to insert my math. So I might have something like solve this equation and pop up that, and it gives me my same user experience. So that's another reason we moved from add-ons to the Chrome extension, because it's the same across all platforms. I also used to say that there was no slides add-ons, but those launched yesterday, so now there are slides add-ons, but because we work in Google Slides as well. Let's go with this speech. X squared plus 4x plus 4 equals 0. And so it just inserts that directly in the question. So that's another way that we make a huge leap from GMath, where GMath just makes a bunch of extra questions after that. We can also put it in, if I want a multiple choice, I can add math in a multiple choice option. If I want parentheses x plus 2, close parentheses squared equals 0. And so that'll put math in a multiple choice option. So if I show that to my students, it has that math in the multiple choice. I'm not a huge fan of multiple choice. I think I can get with EquatIO, I can now use forms to get like better information for my students. So if I change that to a short answer, they can type in here as well. But there's a little blue box where they can insert their math, and we pop up this toolbar, and then they can utilize this to respond to the math. So I could then say x plus 2 squared equals 0. And then my zeros are looking like 6s. Let's scratch that out. There we go. And then x plus 2 equals 0 and x equals -2. And that's x plus 2. There. So now when I insert that, it inserts my thought process directly as that form. And just like I would if it was like a paper and pencil thing. And then when I submit it as a student, the teacher on the form side, what we do is we make it so it looks directly as the student submitted it. So I have multiple line work there that comes in from that form standpoint. So as each of my students are responding, those will come and cascade in one at a time, and I can scan quickly from a viewpoint, do my students understand or not? And then from there, I can jump into the individual form and see, like, maybe there's a student who doesn't understand, and I can find out who they are if I'm collecting their information. So that's the integration from Google Forms. I can just utilize the little blue box to press the button. That is one of our premium features in EquatIO for Google, the Google Forms integration, but I think it's really awesome to be able to allow students to submit responses using whatever method they prefer to a Google form. because previously there's no other way to really submit math easily as a form.
Thanks, John. One other question that did come in, kind of in general for handwriting. Do you know if there's a plugin with a stylus to use for handwriting if people are using a non-touch screen computer?
I do know that one of my friends, Craig Shield, up in New Hampshire, has one of those Wacom or Wacom, I don't know, I've only read it, I don't know how to pronounce it, tablets, the bamboo thing that's connected to his Mac, and he was using that with EquatIO for the handwriting part, and it worked really great for him. So I'm not, so those that worked for him on the Mac. I'm not sure about on a Windows. I'm using a Windows touchscreen. Obviously, the question was for non-touch screens, but I'm sure there's something analogous there.
Cool, thank you. And now, does the math space save your work, or does it disappear if you close the tab?
Yeah, so currently it'll just disappear if you close the tab. You have to save it to yourself. So once I share it, then it's saved, and I have, like my workflow is currently, I just make a bunch of copies. I literally have a spreadsheet with the different uses that I have. So if I go to goo.glek1vps. So my spreadsheet, I literally just make one and then I stop and I share it to myself, so I know what those are. So we remember them, we just don't have a way to show it to you yet. We're making a dashboard where these will all come up nicely. I'll see all the creations I have, and for students, like if they're working on them, that'll work really nicely. And so that is coming soon. Currently, you just have to remember what this short link is. So that short link is always connected to that. So it's not an ideal situation there, but at the same time, if it's shared in like in Google Classroom, you can access that. But the response that you're making, until you share it, you won't be able to access it. So I say I was envisioning a student at the end of a class, like maybe they're not quite finished with it, they can share it to themselves. They can just share it and remember that. Not ideal, but we're working on a better solution. So they can just remember that, and now I can access that current state of that work. So that's the best way to do it, is just share it to myself.
Thank you. Yeah, I should say you'll probably notice that it says that EquatIO Math Space is in preview, and that's really just because there's a lot more functionality, especially in terms of the sharing and the integration with Google Classroom that is eventually coming. And so we know there's a lot more planned for EquatIO Math Space, but this is just kind of the first iteration to show the possibilities of collaboration and sharing. So I think on that note, we've answered everybody's questions. If you do end up having more questions, you can reach out to us on Twitter or via email. I'm sure you will all be receiving an email early next week with the recording as well as the links to download all of the new extensions, or sorry, the desktop apps and the EquatIO Math Space. And you can always ask us questions then as well. We are getting a few more questions in. Since we do have a bit more time, I can quickly, it does work in Chromebooks. That's one question we have. And then one question I missed.
Yeah, the Chromebook is my daily driver. I work with the Chromebook all the time, so I love the integration in Chromebooks.
And then we have a question about in the extension, EquatIO for Google, how do I prevent my equation from getting fuzzy when I make it bigger?
Yeah, so that's the problem that we're working with, and it's if I go in my docs, it's a little bit smaller. So we're trying to work on that spacing size. Currently, this text mode thing, we'll see it in the future bring in there, but there's not a good way to make it so it's not fuzzy based on Google won't let us put in SVG images, which are what we have here, that are really crisp and won't get fuzzy. So if you don't want them to get fuzzy, you have to use EquatIO Math Space, and then you can download the PNG, and then they can be really nice and big, and you can drop them into a doc or something else, or upload that into the insert image. But if I did make it like in my form, I can make that a little bit bigger, but it's a little bit fuzzy based on that pixelization size in there. So we're still trying to attack that in a variety of ways, but it still gets a little bit fuzzy the bigger I make it.
Thanks, John. And could you just remind us what the visual patterns resource was that you mentioned?
Yeah, so I just go to visualpatterns.org, and Fawn went as a collection of 240 plus, where it's literally an awesome way. I love them as starters or problems, if I can just say, like, I use, I think this one, like here's the first 3 patterns, and then you can ask them what's the pattern in step 43. So it's just a great collection of ready to go problems, and then students can answer them. So this is the one that I had built here, you know, how many toothpicks are needed. So those I think are really great once we build them, and I'll share these resources as well in our Google Plus community, the Making Math Digital community, and also out on Twitter. So that's really great that they're shareable in that method. So once I build it once, you guys can use them. So that's, I love the visual patterns from Fawn Wen. She's amazing. Like if she was my middle school math teacher, I would be such a much better mathematician. So shout out to Fawn. And then the open middle problems as well. I love the open middle. So open middle problems. There's a consortium of 4 awesome math rock stars, Q rock star people out there in California. So where they have this leveled grade problems where it talks about some of these problems, and they have these like, how can you, just quick directions, how can you fill in numbers with these things. So that's another great resource where, like this is the top searched one, how can use those directions, which whole numbers 1 through 9, using at most 1 each time to find the largest or smallest possible values for X. So that's a great, I made most of these in like literally a minute in MathSpace, and I can share those as warm-ups or share those with my students.
Awesome. Thanks for those resources, John. And then the last question, I think, hopefully I haven't missed anybody, if we'll be at TCEA, and we will. So we'll also be many other places throughout the year. So if you follow us on Twitter, we'll keep you in the loop of the different events that John will be presenting at, or where our sales team will be highlighting EquatIO. So you can always stop by and say hello and hear the latest. So thank you again, everybody, for joining us this evening. We'll announce the contest winner early next week, and we'll be sending around the recording early next week as well. Thank you again, and keep making math digital and making it together.
Thanks, Dina. I really appreciate it, Dina. Thanks, Kathleen, as well. And thank you to all the teachers out there who are taking time out of their busy days to learn more about how to empower their students. It's awesome. I'm constantly in awe of our community, so thank you.
Okay. Take care, everybody.